Hello class, I wanted to do a video here to go over the midterm lab. This is probably really the most important test that we're going to do for the whole class. So I thought it would be worth our time to take some time to review it. And I've kind of modified the schedule from what I told you earlier this week, just to give everybody time to make sure that they know how to do everything and to practice, because even though we have the open lab days now, you still haven't had a whole lot of time on the robot. So I want to give you another week of practice before we do the actual midterm lab. And I'll be going over that with you here in this presentation about our scheduling. So let's look at the lab itself, the layout here. And if I get there we go. So what's in the lab and how will it be graded and when will we do it? So that's the things that we're going to talk about here briefly. And here's the things that you need to know how to do. So you can be brushing up on these things. And again, we're going to do a practice this next week. So you need to create 3 separate programs to trace basic shapes: a box, a triangle, and a circle. And then you need to add the output indicators to show each program is running. So you can turn on the output lights, and they need to turn on and off at the correct time. So when it starts, each program starts, it needs to have a specific indicator light on, and then that light needs to shut off when that cycle is complete. And then you need to create a loop for each program to run a set number of times and then shut off. So these are all things that we've covered in class, and hopefully you'll be able to do these with minimal problems. Okay, and then you need to add an offset at each motion instruction that will shift y-axis correctly to trace 3 separate parts. Okay, so with the box, you'll make 3 boxes across the work cell, across the work area. You'll make 3 separate triangles, and you'll make 3 separate circles. Now, I'm not going to give you a millimeter measurement. You're going to have to determine what that is to correctly place the shapes within the work area. So we have rulers there that you'll measure. And remember, everything is in millimeters, so you'll have to make sure that you do the conversion, because the rulers are in centimeters. Okay? Still easy stuff. Once you have all 3 shape programs working correctly, you will create a program to control all 3, which we've done several times now. The control program requirements are energize an output indicator to show cycle running, and now this is separate from the indicator to show which of the 3 programs is running. This is the overall cycle is running, so that would be a separate output. So there'll be 4 output lights involved altogether. You're going to call each shape program from the control program. Programs are called based on data in register 55, and I picked that one because I want to get one that's not been used, because those things are so cluttered and I really haven't had time to clean them all off. So we'll just clutter another one with this test. Data is entered into R55 by activating individual inputs. So you use the switches to set the data into R55. And then you create an end cycle input. So you have to add another switch that will stop the cycle once that switch is activated. Okay, so these are all things that we've done in class already. So everybody should have some idea how to do this. Okay, so how will you be graded on this? You must complete the lab with minimal assistance from me. Grades will be calculated by a rubric, and I'm going to show you that rubric here in just a second. and you demonstrate the completed lab, the working robot to me, and then I will save your program to my jump drive for final review and grading. Okay, so those 4 things that we'll use to assess your lab. Okay, so here's the rubric, and this is how we're going to get your grade for this lab, and you can see the categories or the criteria that we'll be using to grade you. First one is robot performs task. It did exactly what the lab told you it was supposed to do, and you were able to load the program and execute it successfully in teach mode and in playback mode. So you can see you can get from 10 down to 0 points for that one. The next one is did you follow the program structure? Program is constructed properly and has all required elements. Again, from 0 to 10 points. Programming of points, you know how to put the points in, the teach points, and the correct motion instructions for that. There's another 10 points. And the biggest point spread here is for the offset instruction. That was the biggest learning thing that we've done here in the last few weeks, and were you able to successfully put the offset instructions in, and did they meet the requirements of making the 3 separate parts within the work cell? Then we have another one on program structure. This has to do with loops and branching, and does all that work properly? And then did you use arithmetic and logical instructions in your program, which you will do, and that's actually relates back to the loop for this particular program, and the logic can also relate back to the digital inputs and outputs that we use, and that's worth 15 points. Pretty important category there. And demonstrate the ability to write advanced teach-pendant programs, and so this is fairly advanced using the registers and the position registers. Did you do all that correctly? 0 to 10 points. Lab is completed in a timely manner. If you take over 90 minutes, your score is going to be severely damaged, but if you can complete it in under 45 minutes, you get full points for that. So that's why I'm giving you another week to practice so you can get really good at this, because I want everybody to do well on this. And then here's the thing about the inputs and outputs. Do all those work correctly? And that's a 5-pointer. So 100 points total for all these categories. And you can look at this rubric here, and so you know what to expect and how to conduct the lab so that you can get the maximum score. And here's the lab. I've got it posted now, and it's published so you can see it. I'll let you can look at that and study it and make sure that you know how to do all these parts, so there won't be any surprises. And then what do we got down here? We got the shapes here, so you can see what the shapes are. Let me scroll. So here's the shapes that you have to do, and I put a starting one and a finish one, and we'll have those so you can lay them out on your in the work area there under your robot. And so when you successfully complete, they will accurately trace around these squares and the triangles and the circle. So you'll have to determine what your offset is. And I don't know if those are exactly proportioned, but it kind of looks like they're off, so I may do a little adjustment on the ones that I actually put down in the classroom. We're not going to use these. We're going to actually use ones that I'll have laid out for you there. This is just to give you an example of what it's supposed to look like. Okay? So there we have an overview of the lab and the grading system. Okay, I did want to go over the class schedule with you here for the remaining 4 weeks of the class. And I've had some questions about when things are due. Well, it's easy to find out by just looking at the calendar here. Just click on the calendar tab. And so, of course, next week, as I told you, we're going to do the midterm practice on Monday and Wednesday. This coming Sunday, modules 5 and 6 are due, so any work you find in modules 5 and 6, those are due. The midterm exam is due on April the 18th, and the midterm labs will be on 19 and the 21st. So then the following week, we will be doing the SOCA C216 exam on Monday and Wednesday, just like we did the last 8 weeks. You'll come into class and sign in on the computer and take the exam, and I'm still working on putting some more information up for you there. And my dog's getting really excited about that. I don't know if you heard him barking or not, but so, and then we'll do some labs that when you get done with that exam, and hopefully I'll have some more good information. There's already some stuff there. Really concentrate on that networking paper that I put on there, and also the input and output connection stuff there about syncing and sourcing inputs. If you had PLC class, then you should be familiar with some of that. So there you go. Let's go into May here now. And if we look at May the 3rd, you're going to have, I'm not sure how this is going to come about, but I put it in this week, the FANUC certification exam, which you have to take over at the Learning Center. So I put it on these 2 nights, our regular lab night, because I don't know when that center is open, and we'll have to schedule you in for those exams. So I have to work through Josh to get that set up, and I'll be letting you know as soon as I get the information for that. So I'll let you know. I'll talk to him about it today, and then I'll post information about that as soon as I find out what we need to do to get those tests set up for you. And then the 10th and 12th of May we'll be doing the lab final, which is basically just a repeat of everything that we've done. It's kind of redundant, but we got to have it on the record. And then your final exam is due, the written final exam is due on May the 14th. Again, so on the modules, when the modules are due, you have to do everything that is in those modules. So that's how you know that they're due. And I did kind of pile them up there on the 2nd, 12th, 13th, and 14 modules are due that week, but we've got to do it to get done. And then the modules for 15 and 16 are basically just the lab final prep, so not too bad. And I think you do. Again, I don't know what's on the FANUC certification exam. I'm going to take that here in about a week or so. So I'll be able to let you know what's up with that, and try to get you some information to help you get prepared for that. So that's really a closed, locked door. We can't really. Josh has been trying to find some information about that exam, and we haven't been able to get any information at all exactly what is on that exam. So we got to send a spy in to find out, which is me. So I'm the guinea pig on this one. So we'll find out. Okay, so make sure you text me, email me, or whatever if you got any questions, and I'll try to get them answered as quick as I can. Stay tuned now for a demo video of the midterm robot lab running. and I'll see you all next week in the lab. Have a good one. Okay, I've got the midterm robot final lab set up here, and I'm going to do a little demo of it here. I've got the main control program that will call each program for each shape and make 3 copies of each with the offsets in it. So I'm going to go ahead and hit my first switch here for the box. And notice my lights come on over there. 109 for the box shape, and then 112 for the end cycle. Okay, so I did the box okay. And here's the triangle, a little faster on that one. And then the circle. Okay, so I've got all those. So now I'm going to go back to the box again, and then I'm going to hit the end cycle switch. So it'll just do this one, and then it should stop, and my end cycle light will go out. Boom. So that's how you successfully do the lab. Seems like a lot of work for just a short program, but the object of the lab is to demonstrate the use of offsets. Also, it lets us know if you've learned how to do all the select instructions and using the digital inputs and outputs to control the program and show indication of what the program's doing. And can you run the program in auto, and have you met all the requirements? So that's what it's about. I did want to say something here. I'll try to. So you can do your program a number of ways. What I did with mine, as you can see here, I did it all in one program to set the data into my control register, which I set up as R20. And so when I flip the switches, it enters the proper number into the data register. And you can do like this with jump labels, which if it creates quite a bit more here. As you can see, I'll scroll down through the program becomes a little bit bigger because you've got all those jump labels in it, as opposed to doing it like we did in class when we created a program to write the data into the register. So we had to create 3 programs. So then all we had to do was call those programs. So it was a lot less lines of programming code, but this way everything's all in one program, and if you need to make changes, you can do it right here. So either way is acceptable. The calling the program is a lot faster, so if you're trying to beat the 45-minute time here, you might want to do that way. So there it is, and we're going to practice again on Monday and Wednesday this week, and then you'll be doing this lab the week after. So I think everybody's going to do great, and that's all I got this time.